Assalamu alaikum everyone. Welcome to our presentation. My name is Taha Ijaz Abbasi and my group members are Muhammad Al-Harsi and Sharjil Hassan. Unfortunately, he could not make it today because he has an exam. So our senior project was about the evacuation planning of the KF-UPM stadium. So first of all, I will present to you our outline. We'll give you an introduction. Then we'll talk about the methodology. Then we'll talk about the parts of our model. We divided into two parts. We had the stadium evacuation model and the campus evacuation model. And finally, we will conclude. So, what is evacuation planning? Evacuation planning is also named as risk management or disaster management. So, the purpose of evacuation planning is to reduce the effect of emergency on a community. Another definition is to move people to a safer location during a hazardous situation. So we applied this strategy in the KF-UPM graduation ceremony. As you know, the KF-UPM graduation ceremony is held every year, attended by about 12,000 people, which consists of dignitaries, families, faculty, and the graduating students. So with each passing year, the number of people are increasing. This results in the rise in traffic. So our graduation ceremony problem was divided into two parts: stadium evacuation model and the campus evacuation model. So the stadium evacuation model is concerned with the movement, with the evacuation of people from inside of the stadium to outside of the stadium. As for the campus evacuation model, it is concerned with the movement of people from the car parking lots to the university exit gates. So when we started this problem, the reason we were interested in it because it has several benefits, some of which are we believe that implementing the improvements or the alternatives, the improvements to this problem, it can help save the lives of many people. Another critical factor is the time. It can help reduce the time in evacuation. So first I'll start with the stadium evacuation model. So when we started this, the first thing we did was we based our assumptions. Before starting the model, we based our assumptions. Some of these assumptions are we set the nearest gate, so people would evacuate from the closest gate. We used the standard speed plus minus 30%. We categorized the people into 5 types: men, women and children, dignitaries, faculty and students. And also the dignitaries, they were given priority in evacuation. They were made to evacuate at the beginning. So based on this, we collected the data on the number of gates, regions and aisles, and we measured the dimension. And we also counted the number of seats in the stadium to know the full capacity. This was used to divide the stadium into a set of nodes, which was used to create the network design. So based on the data that we collected, we found the route time and the capacity. As you can see from the formula, for the standard speed, we took the value of 8,333 centimeter per minute. This speed was set by the Canadian Health Institute. And for the capacity, for the formula for the capacity, the cross-sectional area of person was found to be 3,518 centimeters squared. So as for the conceptual model, this is the top view of the stadium. As you can see, we have regions, gates, and aisles, and we have nodes in the center of the region. So between two nodes, we have resources, and people would evacuate from the path created by these nodes. This is a top view of the regions on the ground. We assumed 3 regions on the ground. This region was for the faculty, this one was for the dignitaries, and this one was for the students. So these 2 gates were allocated to these 3 regions: faculty, students, and dignitaries. So this is our 3D model. This is the diagonal view, this is the top view, and this is the front view of both sides of the stadium. So after the data collection phase and the methodology phase of our project, we were interested in some performance measures. Some of them were the total time for each entity and the total evacuation time. So here, as you can see, if we observe in this table, we can see that the waiting time for entity 4, it's close to 0. The entity 4 corresponded to dignitaries in our model. As I said in the assumption, the dignitaries were given priority, so that they did not have to encounter queues. So the waiting time was close to 0. The total time was found by the summation of the waiting time and the transfer time. As for the stadium evacuation time, it was 14.5013 minutes. The units were minutes. The time was in minutes. So we proposed some alternatives which could help improve the model, our basic model. The first alternative was increasing the width of the gates and aisles and adding the stairs from the lower regions to the field. The second alternative was adding a new gate and increasing the width of the stairs on level 3. So we used the hypothesis test to compare the alternative with the basic model to see if there was an improvement or not. So since we rejected our null hypothesis, it was proven that there was a significant improvement in the total time for entity 1 and entity 2 because of alternative 2. The same was done for alternative 2. Here also we found an improvement, but the improvement was not as significant as for alternative 1. So now my colleague Hamad will talk about the campus evacuation model.
So, Assalamu alaikum. After people evacuate from the stadium, they will go to their cars. Then at that time, the campus evacuation model was started. So we have two main assumptions. First, according to KFBM regulation, that the maximum speed inside the campus is 50 kilometers per hour, and the parking lots will hold its maximum capacity. So for the conceptual model, as we can see here, this is a top view for the KFBM campus. These 3 red circles correspond to the parking lots, and the 2 green for the exit gate. So the people will evacuate from these 2 gates. So to be able to simulate the transportation, we used the guided network model. Basically, whenever we have intersection, we'll use network links. Then with all the network links, we'll create the networks. So why we choose this method? Because it allows us to use networks, also to avoid overlap, so the cars will not cross each other. Also, one more thing, that we to allow us to use acceleration and deceleration. This is snapshots of our 2D simulation. As we can see here, there's 3 types of cars: the red and orange. There is a green one here. Each one corresponds to their parking lots, and they will evacuate from 2 gates. This one, and this is the second gate. So, to measure our performance, we'll mainly look at 2 points: the total time to exit from each parking lots and the total cycle time for the evacuation. As we can see here, for the number waiting for Q2 is 48 and 480 cars. This because that parking building will hold up to 1,000 cars, and it only has 1 exit. So this caused the number waiting high. Also, the total time for each parking lots to exit cars from parking lots to exit to the gate. And we found that the total cycle time for the campus evacuation found to be 85.85 minutes. So, to be able to have a smooth evacuation without the traffic, we proposed 2 alternatives. The first one, to use additional parking lots and make them evacuate from the 3rd gate. The second alternative, replacing that building that will hold 1,000 cars, replace it with another open parking area near the cafeteria parking at the campus. So, as we did for the campus, for the stadium evacuation, by hypothesis testing, we test our alternatives. We found that we tested on the total cycle time. So this is our main objective. We found that the 2 alternatives gives good improvement, so we reject the null hypothesis. This means we found improvement. So in conclusion, evacuation will help society contribute a huge impact that will save lives and save unnecessary deaths. Also, it can be applied in different places, such as Mecca and Al-Medina during Ramadan especially. And Al-Hajj also at the Al-Jawhara Stadium, it can hold up to 60,000 people at the time. Also, Tekafel can get benefit from this to do it in crowded schools to have a smooth evacuation planning. So then I would like to thank Tekafel Competition and our college for giving us to present this our senior design project. And thank you for the audience. If you have any question, please feel free to ask.